Hello, today we're going to be working on Homework 6, Part 1. And Homework 6 is methane burns with 20% excess air. Calculate the adiabatic flame temperature. So, Part 1 of this is explain how the moles of each species in the feed and the product are determined from the reaction stoichiometry and given excess of air. So, first we want to look at what a combustion reaction would look like with methane. So we have CH4, our methane, plus oxygen gives us carbon dioxide and water. So this is the typical combustion reaction. You have oxygen plus something gives you carbon dioxide and water. So since we're not working with pure oxygen and we're working with air, air is mixed of multiple things. And the big one we have to think about is nitrogen, because air is 79% nitrogen and 21% oxygen. So to find the amount of nitrogen that would be in our reaction, we do 79 over 21, which would give us the amount of nitrogen compared to the amount of oxygen. And that will give you CO2 plus water and then plus our nitrogen. All right, now we want to balance our equation. So we have one carbon in the reactants, one carbon in the products, so those are good. And then we have 4 hydrogens in the reactants and 2 in the products. So we want to add 2 right there. That gives us 4, and it gives us 4 hydrogens on each side. Now we have 4 oxygens in the reactant in the products and only 2 in the reactants. So we'll add a 2 there, and that gives us 4 on each side. And then since the oxygen and the nitrogen are from the same source, if we add 2 moles of the oxygen, we have to add 2 more of nitrogen. So that is our balanced chemical equation for this combustion reaction. Now, if we're working with 20% of excess air, so now we have to add our 20%. So 20% excess of 2 times 0.2, that's going to give us 0.4. So let's add 0.4 to our air. So we get CH4 plus 2.4 2 plus 2.4 times 79 over 21 N2 is going to give us CO2 plus 2H2O plus 2.4 N2 plus, now we have to add our excess air on this side, so it'll be 0.402. And that is our final reaction, balanced reaction with the 20% of excess air.